See, in yesterday's class, we have discussed about physical quantities. Okay. So what is a physical quantity?
Quantities that can be measured.
Yeah, quantities that can be measured are known as physical quantities. Example is like length, mass, and time. And what is unit? What is a unit? The
Value of physical quantity expressed.
Very good. The value of a physical quantity is expressed in units. The next definition is fundamental physical quantity. What is that? The
Physical quantity which cannot be expressed in terms of other.
Very good. Physical quantity which cannot be expressed in other physical quantities, or the physical quantity which is independent of other physical quantities is known as fundamental physical quantity. There are how many total? Altogether there are
7.
seven fundamental physical quantities. Okay. Next is what? Base quantity. What is a base quantity?
Units of fundamental physical quantities.
Base unit is the unit of a fundamental physical quantity. Next is what? Derived quantity. What is a derived quantity?
Quantity is derived from other physical quantities.
Quantities, physical quantities which are derived from other physical quantities, or it is combination of two or more physical quantities. They are known as derived quantity. Then what is a derived unit? Unit of a
derived quantity.
Yeah, the unit of a derived quantity is a derived unit. Okay. Next, after that we have supplementary quantities. What are supplementary quantities?
Solid angle and plane angle.
Where plane angle and solid angle. What is the formula for plane angle? Theta
is equal to L by R.
Theta equal to arc length by radius, L by R. And measured in radians. Okay. Next is what? Solid angle. What is the formula for solid angle? D omega equal to
dA by R square.
dA by R square. Measured in what?
Stellarian.
Stellarian. Okay, SR. So these are the values. After that, so we have these are the quantities. Next one is what? We have a conversion technique. How to convert radians to degrees and degrees to radians, that we have seen. Then we have seen the algebra. Yeah, algebra how to add or subtract or multiply or divide. If you want to multiply, so it's in significant figures. In significant figures, we have rules. What are the rules? All non-zero digits are significant. Second rule is if a zero comes between a non-zero digit, then it also is significant. But if the number is less than 1 and zeros after the decimal are significant, but before the decimal are not significant. After the decimal, any number less than 1 and after the decimal are significant, before the zero, before the decimal are not significant. Clear? So,
yes, sir.
When we are multiplying any two, when we are multiplying or dividing any number, like what will happen? The least significant, you should have the answer should be in the least significant digits. And when we want to add or subtract, so both the values should be in the same significant figures. Then only we can add or we can subtract, and the answer also will be having the same significant figures. Is that clear? Is it clear?
Yes, sir.
Yes, sir.
Now, next one is what? Rounding of the uncertain digits. So how will we round it? Like suppose if you are having 2.746, how do we write? I want to convert to 3 significant figures. So how do I write? It is very close to 5, more than 45, 4, 5. So that we can write as 7, 5. Clear? And suppose if it is like 2.743. So this 3 is less than 5. So just keep it as it is, 7, 4. Is that clear? 7, 4. Now next one is what? Suppose if it is even number, 745 and 735. 2.745 and 735. Suppose here, if it is 5, it's exactly 5. It's not less than 5 or greater than 5. In that situation, what do we write now here? 2.74. But if it is 3, odd number, if it is even number, keep it as it is. If it is odd number, increment 1, means it will become 74. Is it clear? They give an increment of 1. Next value. Suppose you have a side value. Is it clear? Is
Yes,
it-
sir.
Okay. Now here, next one is, suppose we have a number. So side of a cube is given by x equal to x equal to how much here? 7.203. 7.203 meters. I want to find out the surface area of cube. Okay, this is cube. Surface area is what? 6x square. And volume is x cube. I want to find out the surface area and volume. I want to find out the surface area and volume. So what do I do now? Surface area is 6x square. Surface area is 6x square. 6 into 7.203 whole square. So surface area equal to how much now? 311.3. Okay. 311.3 meters square. Why did I write that much? Maybe the points might have gone so many, right? 3.1, 311.3, something else it might have gone. Why did we write like only 4 significant figures?
Because in the multiplication, it should get the least significant figures.
Yeah, that is there. But here, how many are there in the side? In multiplication,
4.
yeah, we are using that rule also. But in the side, we have only 4 significant figures. Okay. Next one, we have volume. Volume is equal to x cube, right? So 7.203 whole cube. So the answer here may be 373.7 meter cube. Yeah. So this is the value. Now we'll go for the one more concept, that is what? Division. In division, so we have density. Density is what? Density is mass upon volume. Density is mass by volume. So density equal to what? 5.74 divided by 1.2. So density is equal to 4.8 gram per centimeter. Gram per centimeter. Okay, this is the value. Why? Because we are taking the least significant figures. Clear? We are writing the least significant figures. Clear?
Yes, sir.
After that, we have one more. That is what? Like suppose I have length and I have the width. Okay. So what is error? How do you define error? Uncertainty in the measurement. Okay. Uncertainty in the measurement. Uncertainty in the measurement is known as error. Okay. Now, let's suppose we have length equal to how much? 16.2. 16.2 plus or minus 0.1 centimeter. And width equal to how much? 10.1. 10.1 plus or minus 0.1 centimeter. Okay, so this is the value given. So what are we doing now? We are finding the percentage. The error is given here. The error should be found in the percentage now. I want to find out the area. Area is equal to what? Length into breadth. What the students do? They multiply this with this one, this with this one. That is wrong. Clear? So what are we doing now? First we'll find out the percentage. How? For length, what are we doing now? 0.1 divided by 16.2 into 100%. So what do we get now? The value is around 0.6%. Is it clear? Just take the error by its value. Similarly, for width also, we do the same way. 0.1 divided by 10.1 into 100%. What do we get now? That is equal to how much? 1% here. Okay.
1%.
1%. Okay. Now, after doing this, what are we doing now? Multiply length into width, only the actual value. Okay, area is equal to length into width. That will be equal to how much? 16.2 multiply with 10.1 plus or minus. What is this? 1 plus 0.6%. 1 plus 0.6%. Okay. Now, just copy this, then we'll go ahead. Okay. The next step, what is there? A is equal to what do we get now here? Area A equal to how much? 26. How much it is? 20. You have to multiply this. When you multiply it, 163.62 plus or minus 1.6%. Now what we are going to do? See. So 1.6%. So suppose if it is for 100%, it is 163. So for 100%, it is 163. For 1.6, how much? So what do we do now? 1.6 into 163.62 divided by 100, which is equal to how much? Which is equal to 2.6. Okay. So what do we get now? Area A equal to how much? 163.62 plus or minus 2.6 squared centimeter. So that is equal to what? Area equal to how much? 164 plus or minus 3%, 3 squared centimeter. Okay. So we have rounded off these values. Okay. Clear?
Yes, sir.
Yes, sir.
Okay. Please note down this. Then we'll go to the next question.